Hi all. Today we'll be discussing the last LeetCode problem of 2025, which is last day where you can still cross. So here you're given a grid of size row into column, and initially all the grid is filled with land. So on each day, one of the cell will turn into water. So suppose on day one, this cell got turned into water, and rest all are land. And then on day two, some other cell will be turned into water. Suppose this cell, and so on. So among all these days, you have to return the last day that it is possible to walk from any of the cell in the top row to any of the cell in the bottom row by walking only on lands. And from each cell, you can walk in four of the directions, which is top, bottom, left, and right. So at the end, you just have to return the last day where it is possible to walk from top to bottom. Now let's look at the examples. So the question will be more clear. In the first example, you have a grid of size 2 cross 2, and on day 0, initially all the cells are land. So you can pick this cell, which is in the top row, and you can move in this direction to reach any of the cell in the bottom row. So on day 0, you can reach from top to bottom. Now on day 1, 1, 1 cell is turned into water. So this is all given in one based indexing. So if this is the matrix, this will be row 1, this will be row 2, this will be column 1, this will be column 2. So 1, 1 will denote this cell. So on day 1, this cell got turned into water, but still you can choose to start here and you move to the bottom and you will reach at the bottom cell. So at day 1 also you can reach from top to bottom. Now at day 2, this cell got turned into water, which is 2, 1. Here as well, you can start from the top and reach bottom. So day 2 also you can move from top to bottom. Now if you check for day 3, 1, 2 gets turned into water, which is this cell. So since all the top cells are water, so you can't start from anywhere. So on day 3, you can't reach from top to bottom. And if we still continue on day 4, the last cell, which is 2, 2, this cell also got turned into water. So on day 4 as well, it is pretty clear that we can't reach from top to bottom. So among all these days, you can reach from top to bottom on day 0, on day 1, and on day 2. But in the question, he asks you to return the last day where it is possible. So you have to return 2. So for this case, the answer is 2. Now coming to the second example. This is on day 0. You can of course reach from top to bottom because all are land. On day 1, the first cell is water, but still you can move from here to here. So day 1 is possible. On day 2, again, all the top is filled with water, so you can't move from top to bottom. So the answer will be 1 for this. And finally, if we check for the third example, this is on day 0. On day 1, 1, 2 cell gets turned into water, but you can move from top to bottom in this direction. On day 2, this cell got turned into water. So if you start from this cell, you can't reach bottom, but if you start from this cell, you can reach the bottom row. So on day 2 as well, it's possible. Now on day 3, this cell got turned into water, but still if you start from here, you can move across this direction and you can reach the bottom row. So day 3 as well, it's possible. Now on day 4, if you start from 0, you're stuck here because you can't move into water. If you start here, you will come here, but after this you get stuck. So there's no way you can reach the bottom cells. So on day 4, it's not possible. So your answer will be day 3. Now coming to the constraints, the row and column size will be 2 10 power 4, 2 into 10 power 4, and row cross column will also be up to 2 into 10 power 4. And the cell slot length will be row into column because on each day one cell gets filled. So overall, we will have 9 days given because at the end all the cells will be filled with water. And In the cells, the row of I and column of I will be, of course, less than 1, will be in the range 1 to row and 1 to column. And all the values in the cells are unique. Now let's go over the approach. So one thing is sure that on day 0, you will always be able to reach from the top row to the bottom row. And then on subsequent days, each cell will be filled with water. 4, 5. Let's say we have total 9 cells. So again, on 9th day, it is guaranteed that you can't reach from top to bottom because all the cells will be filled with water, so you can't move. Now let's see. On day 0, you can reach from top to bottom, and suppose on day 1 also you can reach. Day 2 also you are able to reach. Day 3 also you can reach. Now let's say on day 4, you are not able to reach from top to bottom because the water is obstructing your path. Now after this, we can clearly see that if we keep going up the days, the number of water cells will only increase. So there's no way, if you keep going, if the days keep increasing, you cannot reach from the top to bottom. So once you are not able to reach from top to bottom, if you go up the days, you will never be able to reach from top to bottom. So if you see, this is a pattern of the binary search where from starting till some point, some property will be true, and after that, you will always have the property as false. So for this, we can start doing a binary search where we can start from the days where left equal to 1 and right equal to 9, and then we can take a mid. So suppose, let's say my mid is on day number 5. So on 5th day, I'll perform a binary search from the, I'll perform a DFS from the top row and see whether I'm able to reach the bottom row. If I'm not able to reach the bottom row, that means I have to reduce my days. Because if I keep moving to the right, if I keep increasing the days, there's no way I'll find the answer. So if I'm not able to reach, then I'll reduce my R. So R will be mid minus 1. Now suppose my mid was maybe here at 2. So now at day 2, I'll start doing a DFS from the top row and I'll try to reach the bottom row. So if I'm able to reach, then I'll set my answer equal to day 2. And since I want to maximize the day number, which I will be able to reach from top to bottom, I'll set L equal to mid plus 1. So L will be here. So this is what we'll do for the binary search. And now for the DFS, let's look at the bottom grid. So in the question, we have a requirement that we have a condition that we can start from any cell in the top row and we have to reach any cell in the bottom row. So for that, we will start doing the DFS from all the cells in the top row. So first you'll start DFS from here. Let me change the color. Yeah, you'll start DFS from here and you will move here. You'll spread over the array, over the grid, and then you will stop. So here the DFS fails because you were never reached the bottom row. After that, you will see if you can start the DFS from here. But since this is a water, you will not do it. So here it's a land again. So you'll start DFS from here. Then your DFS will spread like this somewhere. And you'll see that you are able to reach the bottom row. So your DFS function will return true because it reached the bottom row. And after this, since you started the DFS from here and you found the answer, you won't check the DFS further. So once you get the answer, you'll just return it. So yeah, that's how we combine binary search with DFS to find the last day where it's possible to walk from top to bottom. Now let's quickly code the approach. So first we'll take the days and initially we'll set it to 0 because on day 0, you can always reach from top to bottom. Now for the binary search, let's say left equal to 1 and right will be equal to the cell sort length. And now let's just start the binary search. So left less than equal to right equal to left plus right minus left by 2. So once you got the mid, you will check if it is possible. So you'll make a possible function. So if it's possible to reach from the top row to the bottom row, so you'll pass mid the row and you'll pass the column, also the cells. So if it is possible to reach from the top to bottom row on day M, then you will just set your days equal to M, and then you'll try to increase your day. You'll try to find a greater day where you might find the answer. So for that, you will set L equal to mid plus 1. And else case in the sense, it is not possible to reach from top to bottom on day M. So you, of course, have to reduce your day in hope to find the answer. So you'll set R equal to mid minus 1. And then at the end, just return days. Now let's fill the possible function. Be Boolean. So we're passing M, we're passing all this stuff, row, column, and cells. Okay. So first of all, on day 0, you will have all the cells as all the cells are land. So the grid is all filled with 0. So you can quickly initialize a grid. Size will be row and column. So all the values are initially 0. Now until day M, you have to iterate on the cells to fill the value. So in this case, suppose you have day equal to 2. You have to iterate on 2 days and fill up the grid with the water. So this 0, 0 and 1, 0, you have to fill it with water. So for that, let's quickly iterate on that. I equal to 0, I less than M. Since it's one based indexing, so we'll start from 0. Since our cells is a 0 based indexing, but in the question he gave it as 1 based indexing. So we'll start from 0 and we'll end till M minus 1. I plus plus. And we'll fill the particular cell with water. So for that, we'll just do grid of cells of I0 and then cells of I1 will be set to 1, which denotes water. So now after this, like we discussed, we will start from all possible cells in the top row, which is currently land, and we'll try to perform a DFS. So j equal to 0, j less than column, plus plus. If the current value, grid of row equal to 0, column equal to j. If the current value is a land, then I'll try to perform a DFS. Row equal to 0, column equal to j, and I'll also pass the row and column and also the grid. So let me quickly fill the DFS function now. So in the DFS, we are passing I and j, and for row and column, I'll just take it as n and m and a grid. So the first thing you'll do when you enter the DFS is you'll check whether you were able to reach the last row, which is if I equal to n minus 1, I'll simply return true, which indicates I reached the last row. If not, first I'll mark the current ij as visited. So for that, I can just set grid of ij equal to 2. So 2 indicates the current cell is visited. And then we have to iterate on all possible directions, top, bottom, left, and right, and do the DFS. So for that, I'll create a directions array of be a 2D array. Be 1, 0, 0, 1, this 1, 0, 0, minus 1. So what this directions array indicates is, suppose you are at a cell and you want to move to the top. So for the top, your row will decrease and the column remains same. Now for the bottom, row will increase, column remains same. If you want to move to the left, then row will remain same and column will decrease by 1. And if you want to move to the right, row will remain same and column will increase by 1. So these are all the 4 coordinates I have added in the directions array. So to the current direction I comma j, if you add any one of this, you will move in any one of the direction. So now let's just iterate on the directions. K equal to 0, k less than 4, since we have 4 directions. X will be I plus directions of k0. And similarly, you will have y as j plus directions of k1. So the first thing you'll do is, when you do this, the index might go out of bound, because suppose if you are at this point and if you try to move to the top or if you try to move to the right, you are going out of bound. So first you'll check whether you are inside the bound. So let's say check of x, y, and m. If you are inside the bound and the current value, the grid of x and y is equal to 0, that means it's a land. Then only you can perform a DFS. Before that, let me quickly fill the check function. So public boolean check x, y, and m. Okay, so for it to be inside the bound, first thing is x should be greater than equal to 0 and y should be greater than equal to 0 and x should be less than equal to the number of rows, and also y should be less than the number of columns. So if all of it is true, then this statement will return true, and if any one of it violates, then it will return false. So now we have checked that it is inside the bound, and we have checked that it's a land. So we can perform a DFS. So in the DFS, we'll call x, y, and m and grid all are the same. So before that, first we'll take a boolean value, which is found, and initially let's take it false. So on each DFS call, we might find the answer. So even if in one of the DFS call we find the answer, then we have to return true. So for that, we'll do found equal to found or DFS. So in all the 4 directions, even if in one of the direction the DFS call returns true, then the boolean found will become true. And at the end, you'll just return your found. And I think here as well, here you're calling a DFS, and in any of the DFS step, if it is true, you can directly return true. So for that, let me just store it somewhere. Boolean, let's say if it's possible. So if it's possible, if possible equal to true, then I'll say return true. And after all, if you start the DFS from all the top row and still you didn't find the answer, I'll just return false at the end. So when you return false, the if possible fails, and you'll go to the else case and you'll try to reduce your day. So yeah, let me test the code. Okay. Also one thing, the cells is given in 1 based indexing and our grid is formed on 0 based indexing. So 1, 1 will essentially mean 0, 0. So for all the values, you have to subtract a -1. And similarly, if you see for this 2, 2, this denotes 1, 1, which is the last cell, first row, first column. Okay, now let me test it. We submit. Yeah, and it works. finally, let's do the time and space complexity analysis. So for time complexity, here we are running a binary search, which will be order of log the number of days, cells dot length. So cells dot length is basically the same thing as row into column, which is n into m. So we can say the binary search time complexity is log n into m. Now inside the binary search, we are just calling a possible function. So let's check the complexity of this. So in the possible function, we are first creating a grid and we are filling the rows and columns. So this, in the worst case, it will be order of n into m. And after that, we have a grid. And on the first row, we are starting a binary search from each of the cell in the first row. So we know that the complexity of DFS will be order of the search space, which is order of n into m. And since we are performing the DFS for each row, it might look like the complexity will be n into m into n, but we are performing the DFS on the same grid. So once you start DFS from here, you might visit some cells. So when you start doing the DFS from this, you won't visit the same cells again because the grid is the same for all the DFS. So you won't have duplicates. So overall, even if you start DFS from all the cells in the first row, the overall DFS complexity will be order of n into m. So yeah, the total DFS and the possible function will have a complexity order of n into m. And the check function is, again, it's just constant. So while loop, outer while loop is log n into m, and inside that we are doing n into m. So overall time complexity will be order of n into m log n into m. Now coming to the space complexity, we are creating a grid of size row cross column. And here we are creating a directions array, which is of size 4. So this is constant. So the only space complexity is the grid we are creating. So space complexity will be order of n into m. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. And let's catch up in the next video. Or maybe catch up in next year.